All right. I would like to spend a lot of tonight continually going over, causing more nightmares and headaches, doing that trinomial factoring that we ended with last night, and then extending it more to some of the trickier types of problems that you need to see. My hope is that by tomorrow night, I will have finished all of chapter 7. Okay, so why is that important? Because that gives us 2 nights of review next week prior to the exam, instead of just the 1 night of review. So if I can work hard tonight, work hard tomorrow night, then we will have 2 nights of nothing but review next week. Okay. Now, I put this up yesterday. Tomorrow night, we have a quiz on chapters 5 and 6. Okay. But remember, this quiz isn't due until Friday at midnight. Okay. Tomorrow, Friday morning, I will have another chapter 7 quiz available to you. Notice my use of the word available, but this won't be due until next Wednesday. Okay. So yes, I'm dumping quizzes on you, but I'm giving you extra time to do them. And then please, next Thursday is our exam number 1, and that's worth 55% of your grade. So you could have 100% right now. If you get a 0 on that, it could drop your grade to an F. It's worth that much. So we really want to make sure that we're focused on doing well on that test. I believe Anne is putting together a tutorial, and I've given her some hints about what's on the final, or what's on that midterm rather, that exam number 1. And she's going to try and help put together some kind of review aimed solely at that review. So you might want to pay attention to her announcements or her emails to get a little bit of extra help. And before we end up tonight, I put some stuff on Canvas to help you a little bit, but I'll come back to that later. Last night, okay, we talked about factoring polynomials And the first thing we talked about was look for what they have in common. The second thing, we said that if there are 4 terms, then we look for something called grouping. And the third thing we looked at is if there was 3 terms, then we looked at something called trinomials. And we used something called AC plus we used grouping. That was the technique that we used. A times C plus grouping. So I want to do a couple problems together, and then I want to stop the recording and let you guys work on a couple. And I want to spend a lot of time on this because there's lots of little twists and turns here. Okay, we use these so often, and there's lots of little twists and turns, and it gets tricky. So let's start by explaining how to do a problem. Okay, so example, 6x to the second minus 5x minus 4. We want to factor this. Okay, and I think we did this one last night. To do this, to do the AC, remember, this is the A number, 6. This is the C number, -4. So AC equals -24. That's what that means. Take the A number times the C number. 6 times -4 is -24. But then we want to run through our multiplication tables very quickly. What times what multiplies to -24, but simultaneously adds to a -5. So you go through your times tables, okay? 2 times -12, 3 times -8, I don't know, 4 times -6. You just keep running through your times tables to the best of your ability as fast as you can until you get some pair of numbers that multiply to make 24 and simultaneously add to make the -5. Okay, well, for us, it turned out to be 3 times -8. 3 times -8 is -24, and 3 plus -8 is -5. Okay, so then what did we do? Well, we took these two numbers and we used them to replace that. We said we have 6x squared plus 3x minus 8x minus 4. So what we've done here, and this is important, and we do this a lot in math, okay? We rewrite the problem because the -5, we didn't like it. We like it better with 3 take away 8. It's still worth -5. It just fits our needs better. Okay. Then after this, we said, okay, I'm going to group these two and group these two. And this is where it got a little bit hairy. So in the first group, we look at these and ask, what do they have in common? What can I pull out of each of them? Now, a lot of you, this is the way I taught this, 6x squared can be broken down into 2 times 3 times x times x. 3x can be broken down as 3 times x. So what do they have? What do they share? They both have a 3x in them. So we talk about pulling out or dividing out the 3x. That's what they have in common. And then what's left over is 2x plus the 1. And we talked about that last night. We said if you pull everything out of that, it always leaves behind a 1. Okay. Now, moving on to the second one. I'm gonna pause and let you guys ask questions and we'll talk about it in a minute, but I'm going through this just to remind us. The tricky part here was when there's a negative here, you're technically going to factor out a negative number out of both of these. What's the biggest number that you can pull out of 4 and 8? Well, 4. I can factor out 4. 4 goes into them, okay? But this is tricky. When I take 4 out of 8x, I'm left with positive 2x. I'm dividing it. In my head, I'm saying negative 8x divided by negative 4. Negative divided by negative is positive. And when I take negative 4 out of negative 4, what I'm really doing is negative 4 divided by negative 4. This divided by this is positive 1. And I forget who it was that kept asking questions, but one of the key features is if this quantity and this quantity are the same. After you factor or group these two together and factor something, and then after you group these two together and factor something, if this little group here is the same, you've done everything correctly. If these two are not the same, then something's been screwed up. So that's your check. If this little group here and this little group here are exactly the same, then you're on the right track. If not, you screwed up somewhere. And usually the place people screw up is they forget to take out, when they factor out a negative, they forget to change the signs in here. All right, we're not quite done because we have to factor the 2x plus 1 out front, okay? Because this is what's called a common binomial. 2x plus 1 is a binomial, and this have it. So we pull it out front, 2x plus 1, pull it out front. Who falls together? The 3x and the minus 4. Okay, and this is our answer. And the last thing I said was some books use a slightly different technique. Mom uses maybe a different algorithm, and maybe they'll have the groups reversed. They'll have the 3x plus minus 4 in front and the 2x plus 1 in back, and that doesn't mean diddly. Both of these are the same answer. Okay, and you get full credit for that. So that's the whole mess. Before we do another one that you've never seen before, questions about that? Anything you want to ask about? How did I get AC? How did I get 3 and -8?
I had a question about the format of the answer. Is the parentheses required on the front expression always?
Absolutely, always, yes.
Okay.
Yeah. Okay. Okay, so 3 and 8. The grouping in here gets a little weird. Again, I fully expect that people can take shortcuts on some of these steps. I urge you, until you become really good at this, not to take too many shortcuts. Okay, it's too, yeah, go ahead.
Sorry, do you mind just going over the second grouping with, I kind of lost you at the +1. Sorry.
Right here?
Yeah.
Okay. All right, let's just go over here and look at -8x minus 4. Just look only at that part of the problem, because that's your question, right? All right, when this number is a negative, you're going to want to factor out a negative number. I'm not coming up with good words. All right. 8 is going to be 4 times 2x. 4 is going to be 4 times 1. Okay, so we can see that they have a 4 in common. And what's going to fall together is a 2x and a 1. All right, the question you have is, what's this negative stuff going? Well, when the front number is negative, we always pull a negative out. Always. If that was the negative number, then we say, I didn't just pull a 4 out, I pulled a -4 out of everybody. Okay, but what's that do? Well, if you didn't change this, let's pretend I didn't change this number. It was a -4, and let's just say I didn't change it. Then how do you check your work? Well, minus 4 times 2 is minus 8x. Yay. Minus 4 times minus 1 is plus 4. Not so yay. My original number was a negative, but by doing this step here, I've made it into a positive. I can't do that. So to adjust for that, I switch this to a positive number. Just automatically. When you factor out a negative, you switch everything inside to the opposite of what you saw. Now, check your math. Negative 4 times 2x is negative 8x. Negative 4 times positive 1 is negative 4. Okay. I'm
So
really
the
unhappy.
negative, the 4 was negative because the 8x is negative.
Yeah, it doesn't matter. Let's say that we had negative 3x plus 6. I just made up this problem. Okay. We're going to factor out not just a 3. Okay, but we're going to factor out a negative 3. So taking a negative 3 out of here leaves x. Taking a negative 3 out of here leaves a minus 2. Because instead of taking out is like for Chinese food, or right now it's all food. Everything you get is now takeout just about. When you take out is for food. For math, we say divide out. When you take negative 3 divided by negative 3, it's going to be positive 1x. When you say 6 divided by negative 3, it's negative 2. So when we say take out, we really mean divide out. So you're taking this divided by negative 3, this divided by negative 3, and that leaves the negative 2. Notice you can check your work by remultiplying it in. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. And you always do this when the leading number was a negative. Doesn't matter what the back number is. That doesn't matter. It's what the leading number is when you factor out a negative. Well, because that's a negative, we factor out a negative. Okay, I'm talking too much.
I have a quick question.
Yeah, go ahead.
So if a trinomial was, for example, like 6x cubed minus 5x squared minus 4x, would the AC method still work, or does it have to be in the x squared x numeral order?
Oh man, that is such a good question. And you're okay. You've got to take out what they have in common first. Let me hold on that question. No, the AC method doesn't work yet.
Okay.
Okay, it will work. But if you factor out first what they shared in common, then it will become an x squared problem. And then you can use the AC method on that part of it.
Oh, okay. I gotcha.
Okay, I'm going to do that later, but I don't want to confuse everybody. I'm confused everybody right now. Enough. Okay. So, but I will get to that.
Okay, thank you.
Okay. So I have no idea if I've clarified things or just made things worse, guys. But what I want to do is pause this and let you guys try to factor this problem. Okay. 6x squared, same thing, plus 13x plus 2. Yeah, 6x squared plus 13x plus 2. This should not have that negative factoring stuff. So give it a try. Let's pause and give it a try. Okay. So AC 6 times 2 was 12. I run through the multiplication tables for 12 that add up to 13. So the only one that multiply to make 12 and add the 13 is 1 and 12. 1 times 12 equals 12. 1 plus 12 is 13. Okay. I use the 1 and the 12 here. So what I've done is I've replaced 13x with 1x and 12x. Okay. To that point, is that okay with everybody?
Yeah.
This already got lost.
You already got lost? Where? How? What?
No. This is the part where I don't know where to go from here.
Oh, okay. All right. Don't scare me. All right. So then we look at the first two here. What can you factor out of those two? Anybody?
X.
Just an X, right? Or not? If I take an X
Yeah.
out of those two, I have 6x plus 1.
Yeah, that's what I got.
Okay, plus, now, looking at the second group, those two, what can I factor out of those two?
Just two.
Just 2, good, 2. So I take a 2 out. If I take a 2 out, remember I'm technically dividing it out. If I take a 2 out, what's left?
6x plus 1.
Yep. Notice my check. Those quantities are the same. So I haven't screwed up yet. Don't give me a chance. I'll screw up, but not yet.
So when you got the x parentheses 6x plus 1 plus 2 parentheses 6x plus 1, when you keep saying that you're factoring out you factored out an x,
Out of the first two.
and that's just because they both have at least an x. And
That's
all.
correct. Exactly. Okay. Same thing with the 12x. 12x plus 2. I factored a 2 because they both have a 2 inside them somewhere. Remember, 12 is 2 times 6. Now we're not done. That big fat plus sign there tells us we're not done. So what we do is we factor.
Professor, quick
Yeah.
question.
Go ahead.
So it doesn't necessarily mean we always have to go with a least common factor, right? Or on these problems.
I think it always is the least common factor. Isn't it?
Professor, I got for the 6x squared, I got 3 times 2 times x. And then for that 12, I got a 3 times 4 times x. Was that incorrect?
Yeah, because you need to break down the 4 as 3 times 2 times 2. Hang on, there's 2 questions going on. First, Richard, I believe you're always factoring out the most that they have in common. I can't think of one time when you don't do that.
Okay, so I'm just okay. I guess what my confusion was just I shouldn't break down the 6 any further if that goes into the 12 or per the problem.
No, okay, because in this step, for a second, you're only focused on these 2 things, 6x squared plus 1x. And so you go off your scratch paper, okay, and you're looking strictly at 6x squared plus 1x. You call this 2 times 3 times x plus 1 times x. And you go, oh, look, they have an x in common. So you bring it out here. And that leaves behind 2 times 3 times x, which is 6x, and the 1. And that was all because you were focused just on the first 2. That's how I got that. Then you change your focus. You say, now I'm going to look at this part of the problem, 12x plus 2. And you break it down as 2 times 2 times 3 times x. I forget who it was that was talking at me, but you had to break the 4 down. You have to break it down all the way to see everything they have in common. Here, the only thing they have in common is a 2. So we bring the 2 out. That leaves us 6x plus, remember when you take the 2 out, you're dividing it out, so there's like a 1 as a placeholder there. So for a second, you treat this as one problem, this is a different problem, and that's how we got to this step. And I think I just answered both questions.
You did. I guess where I messed up was that I put the 12x in front of the 1x, the two middle variables
Okay.
that you have there. I mixed them.
That's not wrong. Hang on. Before I go do another problem, let me redo this problem. That's not wrong. It just is different. So I'll show you how to do it, what you just did.
Thank you.
And I do need to make sure everybody pays attention, because it won't always be pretty like this. Sometimes you're going to run into the question you're asking and you need to know how to deal with it. But wait, we're not finished. Remember, they have these binomials in common. So you have to pull the 6x plus 1 quantity with the parentheses out front. And who falls together? The x and the 2. That is your final answer. Again, remember the argument is the x plus 2 could go in front and the 6x plus 1 could go in back, but the groups are the same and that's all that matters. Okay, really good question. And I need everybody to kind of look at this. We had 6x squared plus 13x plus 2. We figured out that we're going to use 1 and 12. That's not going to change. But what happens if you did it this way? Okay, look at the difference. Here we wrote 1x plus 12x, and that's still 13. But here I wrote 12x plus 1x, and that's still 13. So you're not wrong. Okay, it just is going to be a little bit trickier. So watch how I handle this. First off, is everybody, do you understand that we did this with 1x and 12x? And these are the steps for that method. But you could have just as easily wrote 12x and 1x, and we'll get slightly different steps, but we'll all end up with the same answer. Okay, so focus only on these two, just those two right now. What do they have in common? If you have 6x squared plus 12x, what?
The 6.
6 and an x, is that right?
Yes.
Okay, so if I pull out 6x from everybody, what's left?
X plus 2.
Yeah. Okay. Now, plus, okay. Now, focus only on those. What do they have in common?
A 1.
1.
A 1. Okay. Your first shot is they got nothing in common, but they always have a 1 in common. So we have x plus 2. They always have that 1 if we need it to be there. Notice again, okay, they have the group is the same, so I know I'm on the right track. So I bring this out front, x plus 2, and what falls together if I bring these out? The 6x plus the 1. And so we get exactly the same answer. Okay?
Thank you. That's what I was asking.
Yeah, and that was a good question because you're gonna run into that. Okay,
Didn't 12x and 6x have 2 in common? They both had 2's to make them.
we always want to pull out the most that they have in common. Yes, you're right, they had a 2. But they also had a 3, which means they had a 6. You pull out the biggest amount that these two had in common.
Oh, so whatever I'm like multiplying this to get the 6, when I break it down, I need to do that with the 12. Same numbers.
Yes. Because look at this, 6x squared plus 12x. You break this 6x squared down, you get 2 times 3 times x times x. You break the 12 down into 2 times 2 times 3 times x. 12 is 4, 2 times 2 times 3. You have to break it down all the way. You can't break it down part of the way. And now when you look and see what do they share, okay, well, they both have a 2, they both have a 3, and they both have an x. So 2, 3x, 2 times 3 times x is the 6x. So it's always factor out the most, and this comes back to Richard's question then a few minutes ago. I think you're always factoring out the most that they have. Okay, one more of these on your own, and then we'll go off and do some weird stuff. Weirder stuff. This is weird. Can I erase this example? Yes. Okay.
Yes.
All right. So six x squared plus 12x plus 4. 9x squared, I'm sorry, 9x squared plus 12x plus 4. Yeah, 9x squared plus 12x plus 4. Let's pause. Okay, so I did AC, 9 times 4 was 36. Running through my times tables, what times what multiplies to 36 and simultaneously adds to 12. 6 and 6 is the only one I came up with. Is that okay with everybody?
Yes.
That makes sense. Okay. That means then this problem will become 9x squared plus 6x plus 6x plus 4. Okay. Factoring the first group, what goes into everybody in just the first group?
3.
And
3 times x plus 3 times 2 times 6 x, I mean. So
3x.
it would be 3x.
yeah, 3x. Yeah, you're giving me everything, and
Yeah, sorry.
it's okay. But 3 and x, they both for sure share an x, and 3 is the biggest number I can think of that goes into them. So if we pull a 3x out of everybody, this will be a 3x plus a 2. And that's what you were getting at when you were telling me all the factored forms. Now, change our vision. Okay, look over here. What do those have in common? What's the biggest thing I can pull out of all of those?
2.
I believe a 2.
2.
Yeah, you're all right. Good. So if I divided 2 out, I get 3x plus 2. Okay. I know I'm right. I know I'm on the right track because those two quantities are the same. That's my check. So I pull it out front. This is a little weird. If I pull the quantity out front, the 3x plus 2, who falls together? This other 3x plus the 2. Now, we're both done and not done. That is correct. And at this level, I would give you full credit. However, mom it sometimes will accept this, but what special way do we have to write something if we have two numbers multiplied by themselves?
Ours.
Squared.
Yeah, so this is 3x plus 2 quantity squared. Now, unfortunately, mom is inconsistent. Okay, sometimes she'll accept this. Okay, 3x plus 2 times 3x plus 2. Other time, she insists on quantity squared. Okay, and I don't know what to tell you. The problem,
That's usual.
huh? Yeah,
That's usual.
yeah, yeah. What? Mom's inconsistent? Yeah, my parents keep telling me, well, we like your brother better than we like you. No wonder I'm all screwed up. Okay. So whichever, I'll take both. I will tell you that as we go further into this semester, this format will be really critical for us later on. So if you ever come up with something times itself, try and get into the habit of writing as quantity to the second power, if you can. It will help us later in the semester. Okay. I want to move on to more trinomials, but they're also trickier trinomials. So here we go. All right. Maybe before I do that, any questions about how I did this problem here? Before we go on, make sure everybody's with me. Okay.
Are you still going to show us the easier way that you mentioned last night?
After class, if you stick around.
Okay.
But the easy way, yeah, and remind me of that. I'll forget it. But the easy way requires that you know your times tables inside and out, left and right, and you can add and subtract quickly in your head. Okay, and it is an easier way. It's much faster, but you're doing a whole bunch of mental math real quick. But you know, if you want to see it, I'll show it to you. It's pretty cool. And let me give you this also. Okay, before we started, is my easy way works 90% of the time. Okay. And then if I can't do the problem in about 5 seconds the easy way, I go screw it and I go back to the AC method. Because the AC method will always work. It's just slow. Okay. My way works fast, but not all the time. But ask me after class. Okay. I want you guys to go back, check your notes for a second. Notice that every problem I've done last night and tonight on trinomials always had an A number, a 2, a 6, a 3. There's always a number in the A position. Okay? What if there wasn't? What if we had, okay, so this is a shortcut. Okay, and this is where A equals 1. So for example, what if we had x squared, I don't know, plus 7x plus 12? Okay. We still go through the AC method, okay? We still do this. So there's a 1 there, though. You have to see that. The A value is a 1. Okay.
What's nice and hot?
Okay. I wonder if this is better. The A value is a 1. So your AC is 12. Does the blue show up? Yeah, kind of. The AC is 12. So how do we break down 12? What times what equals 12 and adds to 7?
3 and 4.
Bingo. Now watch carefully. Okay, the magic is going to occur. When the A value is a 1 and you go through the AC method, then here's your answer. X plus 3, X minus 4, you're done. That's it. You saved yourself all this grouping stuff. When the A value is a 1, you can avoid all the extra grouping steps. Okay, did you guys follow that? When the A is
That's
a 1,
beautiful.
AC, yeah, it is. You find yourself wishing, oh God, why weren't they all like this? Okay, my personal philosophy is I didn't want to give this to you early because you'd fixate on the easy way and you'd be ignoring me about the hard way, the harder types of problems. So I wanted to make sure we had a good foundation on the harder problems, and then this trick only works, really important, only works if the A value is a 1. If it's anything else, you got to do this. You've got it.
Professor,
Yeah.
isn't that X plus 4?
Thank you. Good catch. Good catch. Thank you. Try this one. X squared minus 3x minus 18. So I get my AC is negative 18. But run through your times tables. What times what makes negative 18, but adds to a negative 3.
Negative 6 and 3.
Negative 6 times 3. Final answer, X minus 6, X plus 3. Just those two numbers become your answer. That's it. Super, super shortcut. Is that okay with everybody?
Yep.
Okay. Kind of cool, actually. It's kind of, maybe you won't have nightmares now. I don't know. So I'm going to leave that, but I'm going to come
Could you
back.
do a negative 3 and a positive 6?
Question. Negative 3 times 6. Those add up to positive 3, but we need them to add up to a negative 3.
Okay, gotcha.
Okay. So there still is, I'm sorry, go ahead. Somebody said something. Are we okay? All right. All right. Now, I don't think I need to do any more of these shortcuts. I think once you guys see it, you can take advantage of it. Now, if you still want to do this grouping stuff here, you can. It'll still work. Okay. But my God, this is so much faster. All right. Next one. what happens if they give us an extra variable? Example. X squared minus 8xy plus 15y squared. Now, there's all kinds of ways this can be done. This can absolutely be done with grouping, the AC and the grouping, no problem. But I'm trying to speed it up a little bit. Here's my hint. Ignore the y and the y squared. So what do I mean? Do this problem. So I looked up here and I say, oh God, there's all kinds of variables. So ignore the y and the y squared, just ignore them. And do this problem instead without the y. So take a second and do that problem. Factor that. So if life is good, notice there's a 1 here, 1x squared. So I can use the shortcut. My AC is 15. So what times what equals 15 and adds to a -8?
-3.
-5 and -3.
Yeah, and it doesn't matter who comes first or who comes second, -3, -5, whatever. So we can take the shortcut and we get x minus 3, x minus 5. Okay. Now, here comes the magic. Oh, damn, I forgot the y's. Check it out. Stick it in there, you're done. I don't know if they showed up. I just cheated the y at the back end of each parenthesis. Instead of 3, it was 3y. Instead of 5, it was 5y. Okay, now think about this. How come that can work? What's 3y times 5y? 15y squared. It's there. We're just breaking it up. So look at what I did. I ignore the second variable. Just throw it out. It confuses me. Drop the y squareds, all of the y's. Factor the problem as you normally would. Stick the y back in at the end. You're done. That's it. You're finished. It's that easy. So if there's
Professor.
extra variable, ignore it. Yeah, Richard.
Isn't -3 plus -5 a +8?
No. If you lose 3, if you lose 3 yaks and you lose 5 more yaks, you've lost 8 yaks. You're confusing addition with multiplication.
Okay, okay.
You okay with that?
Yes, yes.
Okay.
Does this only work if it's a variable and a variable squared?
Oh yeah, it's got to have a y and a y squared,
Okay,
or a z and a z squared.
okay, cool.
Okay. Richard's question is really good and it's worth talking about here real quick. How do you know that this is the right answer? Well, you could multiply it together. Okay. Like we did in chapter 6, x times x, x times 3, 6 and a half, or you could do it mentally. And some of you have learned something called FOIL. Anybody hear of FOIL?
Yes.
Way back when.
Way back when. Okay. FOIL means first times first. So it's x times x, x squared. Notice first x times first x. Okay. X times x is x squared. The L stands for last. -6 times +3 is -18. Okay, so mentally, we're multiplying this back together to check ourselves. We can do first times first. That's easy in our head. We can do last times last. That's easy in our head. But the oi, okay, is Yiddish for outer and inner. If you look at the inners, that makes a -6x. Inner means inside, the two inners. These would become the outers, +3x. Does a -6x and a +3x make a -3x in the middle? So the oi is in the middle. Okay, so real quick, -6, +3, does it make -3? Yep, it does. So you can check your work mentally by using FOIL. First times first, last times last. The oi is what's in the middle. The two middle, those two are the middle. Those two the outer, outside. So they make the middle. Coming over here, addressing Richard's question. Okay, is first times first, first. Yeah. Is last, -3y times last, -5y is last times last, 15y squared. Yeah. Okay. Check your innies, your inside, that's a -3xy. That's a -5xy. So does a -3 and a -5 add up to a -8xy? Yes, it does. So you can check your work mentally quite quickly using FOIL to help you do things in your head. Okay, so a couple things. Richard, that kind of addresses your question in a different way. Are you okay with that?
Yes, I got it now. Thank you.
Okay, cool. Anybody else? Is that okay? All right, let's try another problem then. Okay, little bit harder to do here. 2x squared plus xy minus 3y squared. Again, we're factoring this. It has an extra variable, the y. Unfortunately, you can't use the super shortcut because it's got a 2 here. So you got to go through all the grouping and all that stuff. So I'll pause the recording and let you guys work. Okay, so first thing I did is I dropped the y. So I wrote 2x squared plus x minus 3. Then I used AC, 2 times -3 is -6. What times what? multiplies -6 and adds to 1x. Well, that would be 3
Positive
times
3
2.
and -2.
Good. So we write this as 2x squared plus 3x minus 2x minus 3. So we use that here. Now this is where we're going to get in trouble. This has that negative trick also. Okay. So we look at the first group and I go, they have an x in common that I can pull out of everybody, leaving a 2x plus a 3. Looking at the second group, there's all kinds of issues here. First off, they have nothing in common. Okay, there's nothing to pull out. So you go, oh, damn, it's that one trick. I got to pull out a 1. But wait, it's even worse. Because that's a negative, we have to pull out a -1 from everybody. And if I pull a negative out, all of the signs flip to their opposite. So there's all kinds of little things happening in this problem right there.
Is it bad that I got 1x in front of the 2x plus 3 one?
Yeah, because they don't have an x in common.
No, I mean on the other one.
Oh,
Like on
having
that
a
one.
1x here? No, that doesn't matter.
Oh.
Okay, no, it shouldn't matter at all. All right, so here we go. They have this was my check. They had that in common, that binomial. So I pull the binomial out, 2x plus 3, factor it out, and what falls together? The x minus the 1. Except I go back and I go, oh, where's the y values? There were y's. There's the variable y up there. Well, this is where we just cheated in at the very end of each quantity, just like that. And we're done. That's the correct answer. I'll write it nicer for you. The correct answer should be 2x plus 3y times x minus, we don't actually need the 1 there, 1y and y is the same thing, but that would be the answer. That okay, everybody, or not?
So when I broke down the second part, I had negative, I kept doing like a -1 times 2 to make the -2x and then times x.
Yeah.
And then I just put the -1 in front of that. What is the reasoning again for switching inside those parentheses to a positive number instead of carrying the negative?
Okay, look at what the original problem was, -2x minus 3. Right there, okay? If you forgot to switch the sign, then look at your math. -1 times 2x is -2x. We're okay. But -1 times -3 is +3, but we originally had a -3. You can't change something just because you don't like it.
Oh, right.
So you had to make that a plus so that it still equals the original. It just looks different.
Okay. So I broke that down to -1 times 3 times y times y. So I guess the 3 was still positive. I should have just kept it positive.
Yeah, but you're ignoring everything I've been teaching.
Ignoring the y's.
Yeah. Notice I'm not even working with the y's. The y's just make my problem more confusing. That's why I wrote over here, ignore the y's.
Didn't you say we could do it the other way though? We wanted just to standardize it all so that we're not doing multiple different ways of doing these, because it'll just mess me up, I feel.
Yeah, I did, but what I don't want to do is then teach a totally different way right now for you.
Okay.
So put a star on that. I'll come back and work with you on that one.
Gotcha.
Okay, it can be done, but what I'm teaching is the way I found most students can remember and can deal with and like. So, all right, moving on. Even harder problems. Hang on, they'll get easier in a minute. I promise you guys, they'll get easier in a minute. Okay, here we go. So when I introduced factoring polynomials, the first thing I said was always look for what they have in common. That has to be our number one rule. Always factor what they have in common. So I'm going to do a problem and kind of show you what I'm talking about here. Suppose we had example 2x squared minus 2x minus 24. Okay. Your first thought is, crud, it's a trinomial. I got to use that AC and that grouping and all that other crud. No, you don't. Okay. Look at this. Do they have anything in common? Do all of these have something in common that you can pull out? And the answer is, yeah, they all have a 2. I can pull a 2 out of everybody. So that leaves x squared minus x minus 12. Okay, notice what just happened. First off, it made all my numbers smaller. Secondly, it turned this into a shortcut trinomial. Remember, when the a value is a 1, we can take some super shortcuts. So let me show you what I'm talking about. So here, if the a value is a 1, we have 1 times 12, our AC is negative 12. What multiplies? It would be negative 4 times 3, multiply to negative 12, but add to negative 1x. Okay. And because it's a super shortcut, I can just jump to x minus 4, x plus 3. Except my answer is completely wrong. You must bring the 2 down. The 2 is one of the factors of this problem. So it's 2 times this mess times this mess. The 2 is part of the answer. You can't just leave it off. It was important. It's going to be critical to us. So the key was, okay, factor out what they had in common, the 2, and then work on whatever's inside. Do whatever's inside the easiest, fastest way possible. But don't forget the 2 is part of your answer. Okay? So again, always, what do they have in common? You factor it out first because it usually makes the problem simpler. Okay? In fact, it always makes the problem simpler. So try this one. And I'll pause the video while you work on it. 2x cubed plus 5x squared plus 3x. This is not a nice problem, but we'll work on it. Okay, to repeat, the first thing that they had in common was an x. So I factored out an x. Then I have this trinomial inside that I'm working with. So the AC was 6 on this trinomial. And what multiplies to make 6 and simultaneously adds to make 5, 2, and 3. So this becomes 2x squared plus 2x plus 3x plus 3. Because I took the 5x and replaced it with 2x plus 3.
Why did you drop the x on the 3?
On here,
Yes,
I
sir.
factored it off of all of these. I factored out what they had in common. I divided x off of each of these. Notice this used to be x to the third. Now it's x to the second. It used to be 5x squared. Now it's 5x.
Why didn't you remove it from the other ones?
Which other ones? I took it from all of them.
Because I thought we were just putting in that 2 times 3 value in for 5, and then we were keeping A and C on the end.
We did.
Yeah, but you changed C from 3x to 3.
Okay, wait. You're not looking at what I did. I factored out what they have in common. That was the first thing I did. I saw that they all had an extra x. So I pulled the extra x off of each thing, and all of them lost an x. So I'm not looking at the original anymore. I'm only looking at this one. Okay, and I'm going to ignore this x for a few minutes. So the 5x did become the 2x plus 3. Okay, but I'm looking at this 2x squared is here, this 3 is here. I'm not paying any attention to the original anymore.
I'll ask you then.
Okay, so here, these two, I can factor out a 2x out of this group, leaving x plus 1. Plus this group, I can factor a 3 out, leaving x plus 1. Because they both have an x plus 1, okay, I can take it out front, and the 2x plus the 3 fall together, except this x that they have in common has to come down and be in front of everybody. Just like over here, the 2 that they had in common came down as part of my final answer. So this is my final answer. They had an x in common. Once I pulled it out, I only work with what's inside. I don't work with the original. But I do bring the x down as part of my answer.
Is
So-
mom gonna accept the x in front of it, or is she gonna want x squared plus 1 times 2x plus 3?
Usually, okay, wait a minute. You asked 2 questions. Not only will mom accept it, she will expect it. The x is part of the answer.
Okay.
It has to be there. I thought you were going with, can I put the x at the end or in the middle? And traditionally in math, the monomial term, the single term, is always in front, followed by the binomial terms. Okay, that's why the 2 is called a monomial factor. It goes in front, and then the 2 binomial factors go at the end somewhere. But the 2 over here and the x over here, they're absolutely required. If you don't put it in, mom will count it as wrong. I will count it as wrong. Okay, or not okay?
Okay, perfect. Thank you.
Okay. All right. So again, guys, go back and look at the first one again. I factored a 2 out of everybody. That changed my problem, and I continued to work only with the inside quantity. But I brought the 2 down to my final answer. Same thing here. I factored an x out of what they had in common, and then the rest of my work was for the inside quantity. But then I remembered at the end to bring the x down as part of my answer. Okay, let's do one more. Get to the last factoring thing in 1 second. So I want to do one more of these where we factor out what they have in common. Okay, hold on. So 5x cubed plus 20x squared minus 105x. I can't stress enough. Think about what they have in common before you start anything else. So, give you guys a little bit of a couple of hints here. I said they all had a 5 goes into all of these, so I can divide out a 5, and they all have an x, so I can divide out an x. So the 5x is what they have in common. Now, looking only on the inside, I see a trinomial, but I'm rejoicing, yay, because it's that shortcut trinomial. The a is worth 1. And that made life really easy for me. So my AC is 1 times negative 21 is negative 21. But then I go, okay, what times what makes 21 negative and adds to that. And I think I get 7 times negative 3. 7 times negative 3 is negative 21. And 7 plus negative 3 is 4. And because it's the shortcut type, I can call this as x plus 7 and x minus 3, because that's the shortcut when a is worth 1, but I have to remember to bring this 5x down, and that is my final answer. Okay or not okay? That's pretty much, God, I wouldn't even want to start categorizing it. That's it for trinomials. I want to move to something still factoring, but it's, in my opinion, easier. And then as soon as I say that, you guys are all going to go, oh God, this is too hard. My brain's going to burst. I've got math flowing out my eyeballs. Okay.
My brain is bursting.
Your brain is what?
Oh.
Yeah, you forgot to turn yourself off. Now you're in trouble. Okay, here we go. Boom. Okay. There is a special kind of factoring when there's only 2 terms. Okay. And I call it dose. Okay. The dose stands for difference of 2 squares. Okay. D is difference. Now, wait a minute. What does difference mean in math? If I talk about the difference between 7 and 3.
Minus.
Minus. So difference means minus. Okay. Of S means squares. I'll explain that in a minute. And dos in Spanish means 2. So I call it dos factoring. Okay. I'm just going to do a problem, explain it to you, and we'll work through this. But the key is it's 2 terms and it's got a minus. So here's an example. Suppose we had 9x squared minus 16. Okay. The key is, can you write the first number as quantity squared minus, can you write the second number as quantity squared? That's where the squares come in. So if I look at 9x squared, can I rethink it? Can I reimagine it in my head as somebody squared? What would that be?
Tres.
Tres what?
X.
X.
Tres X. Yeah, X. And what about 16?
4.
I know, cuatro. Okay, fine. I heard you. Okay. So now wait a minute, we're not done. We're not done, but this is the thinking that you need to go through. 9x squared can be written as 3x quantity squared. 16 can be written as 4 quantity squared. Okay. Here, big drum roll, the answer is 3x minus 4, quantity 3x plus 4. Ta-da, you're done. Wow, what did I just do? Okay, this is a special type of factoring. You'll notice the middle number is missing. There is no x in the middle. If you go back and look at all of our other problems, it was like 3x squared plus 5x minus 6. All of our other problems had a square, an x, and a plain old constant number out here. Suddenly, this one doesn't. It's missing the x. Okay, that makes this special. So there's a super duper shortcut that I just showed you. There's a long way. Okay, but this way works in about 3 seconds. So you want to learn this. Again, can I write the first number as a quantity squared? 3x. Can I write the second number as a quantity squared? 4. Really super important. Is this a minus? If it is, I can continue. So I just take first number minus second number as one quantity, first number plus second number is the other quantity. And again, it doesn't matter who you write first, whether you write a plus or minus, but one's a plus, one's a minus. So let's see how this works. Suppose we had 25x squared minus, I don't know, 64. Anybody want to take a shot?
Five x squared minus 8 squared.
Okay, that's your middle step. 5x quantity squared minus 8 quantity squared, but that's not your answer. Okay, how do you use these, what you just said, to get to your answer?
5x minus 8 times 5x plus 8.
Bingo, that's it. So this middle step here, which I'll put an arrow on, this here or this here, that's only what you're thinking, only your scratch work. But you use that 5x and you use the 8 to get to the final answer down here.
Excuse me,
I'm sorry?
can you write the answer on the second problem a little lower? It's in the square.
Oh, sorry. Yeah, it was 5x minus 8 and 5x plus 8. Is that okay? It's not, it's in the glare. Yeah, it should be okay now. You okay?
So
Yeah,
what
that's
if
better.
the
Thank you.
what if the 64, the negative 64 was actually positive? Would that answer have been 5x plus 8 squared?
No, and you've just asked a damn question. God, I didn't want to get there tonight. But it's a really, really important question. Super important.
We can wait.
Okay. It might have to wait till tomorrow night. Okay. The answer is no, it wouldn't be what you said. Okay. The answer, gosh.
The sum of two squares?
But there is no such thing. That's the whole key. Okay, crap. Okay. I didn't want to get there, but we are, because you asked a good question. Okay. Damn, you guys are too smart. Okay. Look, do you guys know, anybody ever hear of something called a composite number versus a prime number? Anybody hear of prime numbers and composite numbers? Ever?
I heard of prime. I don't know what the composite is.
Okay, what's prime? That's pretty good. What's prime?
The numbers that can't be divided by anything, right?
Okay, or more accurately, can only be divided by one and themselves. But yeah, I understand. So a composite number like 6 is composite because it can be broken down into 2 times 3. 9 is composite. It can be broken down into 3 times 3. Okay, but prime, okay, a prime number like 3, the only thing you can break it down to is 3 times 1. Or 2 can only be broken down into 2 times 1. So composite numbers can be broken down into numbers smaller than the original. Prime numbers can't be broken down into anything smaller than the original. Okay, that's the basic idea for numbers. It turns out that, you're not going to like this, polynomials can be classified in exactly the same way. If a polynomial can't be broken down, okay, technically you write, okay, technically, let's see, you asked the question 25x squared plus 64. Okay, the correct answer is to say prime. It is a prime polynomial because you can't break it down like you could this one. It's a prime polynomial. Now, some books have you write CBF, can't be factored. Okay, so I just got to read the directions, but the technical term is prime. Prime means it can't be broken down. Cannot be broken down in any way. Prime numbers can't be broken down. Prime polynomials can't be broken down. So we just say prime. The key was, this is a difference of 2 squares. This trick that I just showed you only works if there's a minus sign in between. Okay, how do I know I'm right? Because if you remultiply this, if you use FOIL, or you just use chapter 6 and you distribute all this together, you'll get this original. But if you try to break this into anything and then check your work, it'll never check, ever. Ever. Okay. So that was probably more than you wanted to know, but it was a really good question. Unfortunately, it took us into some number theory to be able to answer that. Okay, so and I shouldn't have erased it. Guess what mom throws at you in some of the homework? She throws polynomials that can't be factored, that are prime. And so you have to be aware that they exist. That's why it was a really good question. That's why I actually addressed it. Okay, some polynomials can't be factored any further. So follow the directions on mom. Sometimes she says CBF can't be factored. Other times you write prime. Just follow whatever the directions are. An example of this, I'm going way off topic, but think about this: x squared plus 7x plus 2. Okay, now if I said factor this, if I said, okay, let's factor this, okay, you go, yay, look, it's a shortcut factoring. Yay, I'm happy. AC is 2. Okay, well, wait a minute. What are the factors of 2 that add up to 7? What times what equals 2 and add up to 7?
Nothing.
Nothing. But the directions say factor. And you go, I can't. So this one would be an example of a prime polynomial or a CBF polynomial, depending on the directions. So you need to be aware that some polynomials can't be factored. Okay, now, not many. Okay, I want to see, can you factor, not can you follow tricks. So when I finally test these on exam number 1 or whatever, most of the polynomials I'm going to give you, 99% of them are factorable, because I want to see, can you do all this crud? Okay, but there might be one that's prime. So be aware of that. All right. Damn. Students who ask questions, man, you get me into all kinds of trouble. Good for you guys. Those are really, really good questions. I enjoy them. They also break us out of the boredom of this. When you guys ask really good questions, okay, we get to take some kind of break from learning all this crap. All right, let's go back to difference of 2 squares for just a second. It's got to be 2 terms, 1, 2. It's got to be a minus in between, and you've got to be able to write them as quantity squared. And then you just use these 2 numbers in your final answer. I believe that every single one of you can do this problem in your head. You can visualize the quantity squares and just jump to that answer, and that's fine. So how about this problem? 16x squared minus 49y squared. 16x squared minus 49y squared. I forget if we're pausing or not. No, we're still recording. You want to take a try?
Is it the same as
As a what?
the last one when we just ignore the Ys and put them in?
Yeah, and stick them in later. Yeah, or these are so simple you can just do it with the Y's in there. That's strictly up to you, but yeah. You want to take a shot at the answer or not?
Is it a 4
Is it
plus?
4x?
Oh, go ahead.
Is it 4x minus 4x, and then 7y plus 7y?
Oh, you got your.
I mean,
X's and
closing open
Ys.
parentheses.
Okay, you got your X's and Y's
Sorry.
in the wrong places. Go ahead, try it again.
Oh, so wait. Wait, what did you say? Sorry, I didn't get that.
Okay, so let's go here.
Yeah.
16x squared is what? What can you write 16x squared as quantity squared? 4 and an x, right?
Yeah.
Okay, minus, what about 49y squared? What can you write it as?
7y.
7y.
Good.
Sorry,
So-
I guess I skipped that part. I don't know.
Well, that's okay, but you absolutely, you have to think this part. You don't have to write it down, but you absolutely have to think that part. Okay, so why am I thinking of that? Because that means your answer is 4x minus 7y and 4x plus 7y. You use the 4x and the 7y and you put it down twice, but one of them is a minus, one of them is a plus, and it doesn't matter which. Yes or no?
Yeah.
Yes.
No.
Okay, what no?
Oh, that's just me. The usual. I'll meet you after class.
I can't do all of these after class.
I know. I'm just letting you know I'm here.
Okay. All right. All right. Tomorrow night, number one, we have a chapter 5-6 quiz, but remember it's not due tomorrow, it's due by Friday night. But I will give you time to start it in class. Okay. Tomorrow night.
Sorry, can you say that again, please?
Tomorrow night, we will have a chapter 5-6 quiz.
Okay.
Okay. It will be around 8 o'clock, whatever, but it's not due until Friday night. So you have plenty of time to work on it. Okay?
Is it timed?
Nope. I took all the timing off. I'll double check it before I do this. I said that last time and screwed up, but I'll double check it. It's not timed.
Thank you.
Okay. I want to show something. Tomorrow night at the start of class, I want to finish off all of chapter 7. We only have about 2 more things to talk about so that you have the entire weekend to work and you can work on that quiz and everything. But I want to show you something here. I'm going to my Canvas. Yeah, there it is. Okay. Going to my modules. Can everybody see my Canvas?
Yes.
Yeah, okay. All right, good. So I'm going to my modules. I'm coming down, and a couple things I've added. Now, this is me. Maybe I should go into student view. Boom. Come on, wake up. All right. I'm in student view in Canvas. I've opened up exam number 1. And on this, I'm not going to go over tonight because I'm not going to bore you. You can do it yourself. But I talk about how the exam is organized. Okay, it's on Canvas. But this one down here, where it says topics on the exam. Okay, I want to show you this. Wake up. I'm telling you exactly what's on the exam. There's a multiple choice part of the exam, and I'm telling you it will have this number of problems. It will have 3 linear equations. Okay, it will have 5 polynomials that you add, subtract, and multiply. Okay, it'll have all these. Then there will be another part of the exam that'll have 19 questions on it. Okay, and I'm telling you right here all the types of questions it will have. Okay, so when you get to the exam, there should be no surprises. And Anne is putting together a review to help you with some of these topics. Now, I don't know if she's going to have an extra review. I don't know if it's going to be doing her tutoring time, but she's putting together a review to help you guys prepare for this exam. So you might want to really pay attention to any of her emails or any of her announcements. Okay.
Can we get her email from you?
I believe, hang on a minute. If we go to the modules.
Should be under her link, right?
Yeah, that's what I'm trying to get to right now. You're right. If we go to Anne's tutoring, okay.
I can show you how to email her via Canvas too.
Okay, she has all of these things here. There's tutoring information, and I believe, I don't know. Yeah, there she is. She talks about her email and how to get a hold of her and all kinds of stuff. So it's already, all of this is on Canvas. Okay, so anyway, I want to make sure you guys all saw here the stuff I've given to you about the exam number 1, which is next Thursday, starting at 6 o'clock. Okay, there'd be no class other than you just start the exam. So you guys got a lot of stuff to do in the next week. You got to get ready for chapter 5, chapter 6, chapter 7, and then this entire exam. Okay, let's go back.
Is the exam timed?
Nope. Well, okay, I'll be a smart ass. Well, that's not right. I shouldn't have said that. It will be due by midnight on that night. So you have whatever it was, 29 multiple choice, 19 show your work. You'll get it at 6 o'clock. It's due by midnight. So in terms of, is it timed? Yeah, you'll have 6 hours. 6 hours should be more than enough time to do the exam.
Thank you.
Okay. Actually, I lied to you. The multiple choice is timed. I believe you'll have 80 minutes to do that, to do 29 problems. Read that thingy I just put on Canvas. It breaks it all down for you. Okay, with that, I'm done. First thing I want to do, so you guys can check out. Somebody asked if I can show you the fast way, the way that I factor. Okay,
Yes.
a fast way. Yeah, do it fast. Okay, so I want to do that first, and then I want to do some problems with Philip, and then I want to do some problems with anybody else's around. We'll bounce around, but I want to show you the fast factoring of trinomials. So if you want to stick around, great. I'm going to pause the video. I'm going to actually stop the video because